Now let's try to learn about Lambda properly. So Lambda, what happens is there is two input that we can take. Like there is a push method that from a push event service we can send the data to a Lambda, and there is a pull event. So we can see two different services. Like there is API gateway that can push data to Lambda, and there is, for example, SQS. From SQS, Lambda can pull the data to and use it. So these two different methods. So this can help you in different AWS serverless interviews, right? And this is how Lambda behaves. So you have to give data, or it can also pull data. If you go inside AWS, then we can see that this is kind of telling us about why Lambda, and this is telling us about the runtime performance. So there are different runtime available. Like you can see Node.js is available, Python is available, Java 28. I think it's also updating over here. Okay. So the runtime will select. The same runtime will be applied to this Lambda. Now it can also I can update the CPU. I think the maximum I can do is of 10 GB, right? So let's do 10 GB of memory, and the maximum timeout I can do is 900 milliseconds for Lambda. This is also architecture. I think this architecture is the core server architecture where the Lambda will run. And also ephemeral storage, I think what is the maximum ephemeral storage for Lambda, right? So I think 10 also 10 GB. So basically this is a temporary directory that Lambda has that it can use to store data. So 10 MB I have given. There is an option of reserve concurrency. So what happens in reserve concurrency is that you get 1000 reserve concurrency throughout a region, right? And let's check it. What is reserve concurrency? So reserve concurrency versus provision concurrency for Lambda. Yeah. So basically what happens here is that in-source function allows a dedicated pool of capacity, preventing it from throttling by other function, and limit its max concurrency. Okay. So the provision concurrency is basically predefined. So pre-initialize the function. So it doesn't have to go in the cold start way, right? Because what happens with the Lambda is it's not always started. What happens with cold start is when you invoke a Lambda, like let's say the API gateway will push the data to Lambda, or SNS from SQS, Lambda will pull it. Then there will be a short delay that is called a cold start. It means that you have to Lambda has to pick the the VM, the virtual machine, and it has to decide what memory we have assigned to it, and then it has to create the runtime. Like runtime is Node.js, and then pull all the dependency inside it, and then it will run. So that's the thing. And the time it takes, it doesn't take it to run your execution. It takes it to start itself. And that's called cold start. So what happens now is if I give reserve concurrency, then I think these many Lambdas will be a kind of warm start. Like this already will be started, right? Reserve concurrency, on the other hand, is like instead of function always has a dedicated pool of capacity, right? So what happens is when we try to hit Lambda, then it gradually increases its concurrency. Okay. So concurrency, let's say that we send 10,000 requests to the Lambda, and it will start with 0, then 10, then 50, then 100, like this, right? It depends upon how, and if I give 100 reserve concurrency, then all the hundreds, 1000 will be used, correct? Then there is a event source, sync API, a sync stream consumer. Okay. So basically what we can do, let's say that we have Kinesis, right? So from Kinesis we can give AWS Lambda, right? So we can add AWS Lambda, and we can tell that this Kinesis stream is kind of a stream mode, so, and it will then Lambda will be the Lambda will take all the data and it will stream, something like that. Okay, now let's focus again on Lambda. Then there is runtime performance that you understood, cold start you understood, event source mapping I told you about. Batch size is how much data it can take for one event. So let's say that if batch size is set to 10, then you send a message and then it will take the data, yeah, and will start processing it for those 10 messages that will come to Lambda. So SQS is getting, let's say, 100 messages, then it will need 10 lambdas to invoke, correct? That we can set, for example. So let's see what happens about overview and the service endpoint. Okay, we can decide also which one to give, and also we can give the concurrent execution per region. 1000 function timeout that we have decided 900 seconds. That is 15 minutes. That is the maximum memory time that Lambda can run. Deployment package, and this deployment package consolidator, functions and layer storage, function layers, and this, right? So these are different asynchronous payload. Okay, this is how much max, I think max how much data it can take. Function resource based. So these are our different set of methods that we can set for Lambda. Now let's see what happens, and let's try to add a path to route. Let's make it post call, and let's make it create user, for example. Okay, and let's make another route and let's call it get call, and this is get user. So one is to get user, one is to create user, and let's get another route, and this is for let's say create user, get user, and let's say delete user, right? So there are three, and this could be let's say delete, or you can use post call as you like. So these three different API gateways, but there is only one Lambda. So now what we can do, this we use just to showcase how pull and push method works, so we can remove it for now. Now because we are trying to understand all about the Lambda, how Lambda connects with API gateway, and basically let's say this is for a push type of event. Okay, now I'll go ahead and I'll drop another Lambda. Okay, I'll try to connect the get user. So let me also rename this Lambda. So this is what, this is create user, correct? This is create user. This is what, this is get user, correct? Now I need another Lambda that is for delete user. So three Lambdas, their basic methods and basic work is one is kind of create user, get user, and then third one is delete user, correct? So this, okay, now let's try to increase the memory of runtime performance is okay. Let's try to make it 10k. So we are selecting the maximum that is available for a Lambda, right? And let's do for same for this 900. Now what about API gateway, like how much data it can take per second, that we need to check. Like general setting, API regional routes is giving season deployment. Okay, rate limit is 10,000 per second, I think. Yeah, throttling rate limit is 10,000 per second. Okay, I think we can increase it. Rate limit is 10k. Acha, rate limit is given 10k. Okay, pre-route throttling. This is enable individual route. Okay, authorization is open. We'll do JWT. Right. So none. Okay, none also is okay. Possible JWT is also possible. So now these three are connected. Chords, enable chords. Okay, and then logging, custom domain names. You can decide a custom domain over here. Okay, cool web application firewall. Right, now let's try to simulate it. Let's first save it, and what happens if I click on simulate, and this is for 100 million. Okay, let's do it for 10 requests. Right, so 10 request is 10 requests per second, okay, then it will cost us around $365 a month if 10 requests per second will come. Okay, what about if I increase it to, let's say 1000, or let's say 1000, start. Okay, 1000 requests per second. Every second it will get continuous 1000 requests. So it means per month, like per hour, it will get around 360 multiplied by 1000, right? 1000 and multiplied by how many hours? 24 hours multiplied by 30 days. So this is around around 2.5 billion, right? Request, and that will cost us around $40,000 or $35,000 a month. Okay, what about if you do the ramp? Ramp means, let's say that every 30 seconds or let's say every 10 seconds it will start increasing the request, correct? Or it will increase by 5,000. So let's see, simulate. Currently it's going like, let's say 1000. Current RPS is 1000 now. Okay, 3 now. Okay, in 10 seconds it went to from 1000 to 5000. Now the cost is, and it's concurrent, it's not stopping. Every second it's 5000 requests going on. Let's try spike. So 1000 initially, and every 10 seconds for duration of 5 seconds it will spike. Okay, start simulating. Now the cost has been $35,000 per month. Okay, like it would be better if this application can tell us like how much. Okay, great. Now this is going red totally. Now okay, now it's 1000. Understood. So every 10 seconds it will spike for 10,000 requests. Now spike 10, 9, 8, 7, 6. It's not spiking. Okay, I think it's spike at 10 seconds. Okay, I think this is for the first time it will spike. After that it will not. Now stop it and let's try wave. Start simulation. 1000. Right. So these are the different ways, and for each of the different way we understand how much cost it will take to kind of run these lambdas through API gateway. Now what will happen if I, let's say, try to write something from this API gateway to DynamoDB, for example, and all this lambda will try to write to the DynamoDB. So one DynamoDB place, because DynamoDB is basically, we'll cover in a different tutorial, is basically like doesn't behave like an RDS, or let's say if I'll take RDS, mention RDS, right, and I write it here also, and also we can take, let's say we can take Redshift, correct? Redshift is there, then Redshift I can write. Okay, so it says that you cannot directly connect with Redshift, right? From, what about Redshift serverless? You cannot, this connection is not supported for Redshift. Okay, means I think you cannot directly connect Redshift with Lambda directly. Yeah, so now one RDS write, and one Lambda is writing to RDS, and all three Lambda are writing to DynamoDB. Let's try to simulate for 1000 requests. So there is no problem, but the cost has drastically increased. Like every second it will write 1000, then the monthly cost will be around $50,000. But it has to run every second, means all these three Lambda is writing to this DynamoDB as well as this, because there is only one Lambda writing to it. Let's try to make all the three Lambda writes to it. Earlier the cost was how much, 50,000. Now let's see how much it will cost if I'll try to write it, let's say with all the 3 lambdas, yeah? And what is the system? Basic, okay, region, standard, FIPS, okay, different protocol is there and different endpoint is available. Service quota is also there. That how much authorization per DB security group, custom endpoints per cluster. Okay. Now let's see what happens if I try to write like this. Simulate. So let's first save it. Save now. Saved. And now let me start the simulation. So cost is almost same. I think RDS did not increase the write cost. So I think I don't know is RDS write cost. Does it take any money to write it? Then also include per making write effectively free of a distance. Oh great, it's free. That's exactly what it's doing. It doesn't change, the cost doesn't change when we try to increase the writes in here. Okay, what about if I'll do so, let's say what about I'll take another API gateway, okay, and I'll don't take API gateway, let's try to take Kinesis, right? Kinesis, okay, and this Kinesis, just trying to understand how much write cost it will increase if we'll increase the cost, the write, like rate per second. So I'll take Lambda for example, and Lambda cannot connect to API gateway, I guess, no. So Lambda sharding can happen. Lambda can write to, let's say where event bridge can maybe filter and can send data to API. No, it cannot. What about again SNS sending and then again sending to SQS and then sending to API gateway? No. So how API gateway will be connected? That's the point. Okay. So let me remove all this. So API gateway can connect with CloudFront, correct? Yeah, CloudFront, understood. So now you get getting a point, right? So how much with this I think we'll be able to understand how much cost the project will take, correct, to run or to build an AWS environment. What about if I'll take, let's say what about CloudFront? If I'll take CloudFront, so CloudFront can write to API gateway. That's nice, that's doable. And what's just I want to understand how much cost it will increase. Let's say that it's 1,000, so it was 1,000 requests per second, and it was $45,000, and even added CloudFront. Okay, it's almost the same. It's almost the same, right? And what about if I'll add one more, like DynamoDB is there, means maximum what we can do is we can try to add route, okay, and let's say this is a post call, create user, get user, delete user, and login for example, and login, yeah, is there. So but per second login won't happen, right? That's a different story. But the thing is, every API won't happen. Will be doing 10,000 requests per second. There is a hypothetical situation that 10,000 will be create user, 10,000 will delete user, 10,000 will be there. Yeah. The best way to understand this is with this another concept of how trading works. So let's say inside trading, what happens? You have Kinesis, correct, and then this get data from upstream, right? And then this has to flow data somewhere. So it will take Lambda, for example, yeah, and this lambda is, let's say, again is a kind of a lightweight lambda, and this lambda can take data, and then what it can do, it can maybe send to SNS, right? And then so what I want to do is I want to create fan out already, but I want to do, what do you call, DynamoDB write with multiple lambdas to see, like, but this is totally different scenario. So this is different scenario, correct? But what we can do, let me try to create another project, okay? And let's call it a trading app, okay, and create it, and we can do Binance, for example, Binance trading, okay, and let's go there. Let's connect Kinesis here, and let's connect Kinesis here, and Kinesis will go to AWS Lambda, because that could be the consumer, or you can do Firehose and then basically once you do, let's say, Firehose, right? AWS Firehose connects with S3. Basically, yeah, we need to have S3. I think this needs to be checked, that why this connection doesn't have, because we need Glue, I guess. Glue does connection between S3 and Firehose. So by the way, we are not looking at this right now. Let's only focus on Lambda. So again, in the AWS Kinesis stream, what is happening is we are trying to connect, but let's say the whole goal is 10K RPS, okay, rate per second coming. This is lightweight Lambda, okay, lightweight Lambda. Just trying to understand how much the cost will increase, and what would happen is Lambda is there, because this will connect to Lambda, and then this can write to, let's say, I can write to RDS Aurora, and I can also write to DynamoDB. DynamoDB is good, but why do you want directly write to DynamoDB? Okay, let's see, and let me increase the capacity of the Lambda to 10 GB, because in the previous example it was 10 GB, and let me also increase this to 900, okay, and then try to simulate it, okay. Let's see what happens, and this is 1000. So for 1000 it's coming around 12,000, but there is a single Lambda, correct, and also 2% cold start is there. So what happens if I do this Lambda, okay, break this connection from here and try to drop it to SNS, so that I can do fan out again, and I can use SQS, yeah. So one SQS, another SQS, another SQS, 3 SQS, okay, and 3 SQS, and let's say all of them connect to Lambda. 3 Lambda as the previous one. Now, so what was the difference between previous one and this one is, previous one we had API gateway, now we have Kinesis stream, so that can take more than 10,000 requests per second, but API gateway will kind of throttle, because that's the maximum limit, 10,000 API requests per second it can handle. Now let's do connect this and connect this, okay. Now let me try to run this, simulate for 1000, $33,000 per month, okay, and this is only doing 3 Lambda, okay. Now what happens, as a similar way, we get RDS, and we are trying to update RDS as well with the Lambda, and let's see how much the cost will increase if we'll try to kind of add the same, because there is no write cost. But what if this kind of so there is a very good benefit using Kinesis in front of Lambda and then transferring it, because the cost doesn't change at all, and we can have 2 DBs, right? Okay, what about if we'll add elastic cache so that we can return, because see, the elastic cache would be very beneficial. Like, what if I'll do this, right? And from here the user can read the data, the DB soon time, because here what we can do, here we can apply some transformation. Okay, transformation lambda 1, and then a similar way we can have transformation 2, similar way we have transformation 3, and we can store analytics data over here inside DynamoDB, right? But elastic cache is there that will take the data and it will show to the dashboard. Let's try to simulate it. For 1000 requests coming per second, the cost is nearly the same. What about if I'll go to 50,000 requests per second? Okay, so this is throttling. If Kinesis stream is throttling, I need to check what add more sart, current 16. Okay, stop. Let me add around, I think how many sarts Kinesis can make, and what is each sart limit. Okay, let's see. Kinesis diff support defaults of up to 10,000 sart per stream in main region, and higher limit 20,000 selected regions. Okay, and the higher quotas available upon request. Okay, great. 1 MB of 2 MB. The total sart is 10,000. Write capacity is 1 MB per second. Read capacity is 2 MB per second. Provision. So okay. So let me define the total number of sarts that you can take. Retention, serverless, throughput planning, right? Blah 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 blah. Put records, Kinesis, blah blah blah. And what about batch size 1, batch size? Okay, from where we can do the sarding? Okay, it's sarding. Sart per region 20,000, that's okay. But why retention hours? Enhance fan out consumers 20, 50. Enhance fan out consumers 50. But how I can increase it? Like, I want to increase the SAR, like still getting error, throttle, percent error, stop. SARs 4. From where I can update the SARs? Let me check. 1 second. Let me check. 10,000 stream is retention is 24 hours. That's okay. Throughput is there. On demand scale is there. High cardinality key, it's okay. And then Kinesis producer library, KPL, put records 1 MB. And aggressive retries, consumer start with this batch size 100. Okay, I can increase the batch size till how much? Max batch window per second. Enhance fan out toggle. Enhance per stream is 50. Okay. The resarding is this. This is the benefit, of this product, of using it. Basically, you can understand every bit of an AWS service that's available. I'm just trying to understand how, from where I can increase the number of. Let me know if you know it. Standard on demand. Enhance fan out consumers per stream 50. Consumer per stream 50. Acha, okay. I can add 50 consumers per stream, it means. Okay, so it means if I add another lambda, then what will happen? if I'll add another Lambda, then what will happen? Simulate 40,000. 4 shards. Kinesis is throttled. Now that's a problem. I'm not able to increase the shards in Kinesis. There must be something. But the whole point is, here we understand, like let's say for 40,000, let's say if you go for, let's say for 10,000 per second request. Now every second 10,000 requests we are getting. 4 shards, and this much error we have. Okay. Add more shards, right? Stop it, and let's try to simulate it again. Get recommendation. So yeah, now this Lambda is having issues of errors. Okay. Increase Kinesis shard for 10k per second. Shard count 8. Okay. Let me see if we can apply it. Applied. Shard count is 8. Okay. Increase memory. Okay. Apply. Increase transformation 2. Increase this. Increase memory of Lambda. Cost optimization critical. Implement Kinesis enhanced fan out. Enable auto scaling for RDS. Right. Let's try now. Stop it and then save it, and then let's try. Oh goodness, 10,000 is taking. 10,000 requests is taking now. The shard has become to 16. I need to check from where it has updated the shards. Now let me go to, let's say not 30, let's go to 20k, 20,000 per second. Now it's breaking. It's giving around how many error? 20-15% error. Okay. Now I'm getting the recommendations. Correct. But by the way, the cost is also increasing extremely high. And the maximum thing, okay, the cold start problem is there, but there is no DynamoDB and RDS. RDS is also having problems. 10 millisecond. Okay. It can write it. No problem. Okay. Add node, add SQS before AWS Lambda. Okay, to throttle it. Okay, right. Critical implement fan out architecture. This is really nice. This is really great product where we are trying to simulate how much money and how the fan out will take. So yeah, well, the whole point was learning about basic like Lambda, Kinesis, SNS, SQS. Hope you like it. Yep. I'll prepare one detailed video about how to properly build an infrastructure